Good afternoon, ma'am.
Good afternoon, madam.
Repeat
Rajeshwari has
sir.
a question.
I
Yeah,
have
yeah.
one question, sir.
Yes, sir.
Yes,
Because
Yes,
sir.
Miss
this
Rajeshwari.
is based
Yes.
on EM wave, microwave.
Yes.
Will it cause any health hazards on the human
Sorry.
body?
Yes, actually, one of the main concerns why people don't go for electromagnetic waves for the biomedical application is radiation problem. They think that it will cause cancer. But here we are using very low power, low intensity, which is
Oh,
not harmful at all. If you talk of, in Russia, they use kilowatts, megawatts power to basically, harm people. Embassies have those kind of radars in there. But here we are talking of microwatts, which is negligible. Much more than that you get from mobiles.
okay, the low power devices.
Yeah, very low power.
Yeah, thank you. Yeah, I find Rajeshwari ji has a question.
I have also a couple of questions to
Yeah,
ask Satyan Gupta. It will be better to have a 1 hour session of him at one time.
yeah,
So I want to represent it to you, Mala, about this because it is very emerging technologies.
yeah,
Blockchain.
yeah. Sure, we'll do that.
That's one my request. And one
Yeah,
more thing, Gupta, R.K. Gupta has told about the disadvantages arising in the digital transmission and also implementation problems and other things they are
the
facing.
challenges. Yeah,
Challenges
things are
also.
your
So that also be better to have it once, if possible.
okay. I hope you are able to hear us, Mr.
Anyhow, we
Singh.
have done excellent deliberations by eminent personalities, and this I can say amongst what I attended in the recent days, this is the best conference. Though it is on
Thank
the
you very much, madam. So nice of you. Thank you very much. Mr. Singh, actually, there was a question from Professor Rajeshwari.
sir, one thing in the digital transmission, how to arrange at low that is ISN, high signal to noise ratio. High signal to noise ratio. You are on mute.
You are on mute, Mr. Singh.
Yeah, is it okay?
Yeah.
Is it okay?
Yeah,
Am I
yeah,
audible?
perfect.
Okay, sir.
Yes, yes.
How to achieve ISN?
Yeah, ma'am, I will. Yeah, in fact, what I will say is that while digital came into our system, so noise problem, signal, of course, a big problem in broadcasting, no doubt analog mode, and that's why when we said that there is a digital broadcasting, we call it the reception of the digital broadcasting is studio quality. So when I say studio quality means whatever is there in the studio, the same thing you will receive in your digital receiver. The reason is very simple that all those noises, etc. When we convert everything into bits, and then it is received. So if there is any noise, naturally it will not be there. That's why the signal to noise ratio in digital is very very high. Signal to noise ratio as compared to analog transmission.
Then log. And one more thing, sir, how to minimize the quantization efforts? Because for
Quantization, of course,
digital,
it will be. I mean, whenever you are digitizing only the two process, sampling and quantization. So when you
quantization
go to the
error.
when you go to the quantization, as we all know, that the complexity will increase when you increase the quantization. That's why in audio we use 16-bit quantization, whereas in video we use only 8-bit quantization. But that depends upon the experience. When audio hour, when I am teaching and I ask the students, what is more sensitive, is it our ear or eyes? That is very simple question, and then naturally students also get confused. It is our ear which is more sensitive than our eyes. So we can fool eyes. That's why we reduce the quantization from 16 bit to 8 bit. But as far as audio is concerned, we have to have higher quantization. But at the same time, once you have higher quantization, that means complexity of the circuitry will also increase. You have to work according to that. So on one side, low quantization will help us, but to certain limit. And that's the reason that why for ear and for eyes the different quantizations are used.
Thank you, sir.
Okay. So,
Sir, why mostly uplink frequency will be high and downlink frequency will be less in the satellite communication?
Because the atmospheric losses, to maintain the atmospheric losses in the downward side towards the user end, the frequencies are kept low on the downward side so that you don't require very complicated receiving systems. That too, a very sensitive signal which is coming from the satellite. So you can uplink 3 kilowatts from 3 kilowatts of RF power from the earth station. You can forego 196 dB loss in the uplink. Whereas on the downlink side, you are using, at best you can use about 150 watts TWTA, whose dBWV in respect of power which is 20 times lower than the uplink from the ground station. And therefore it's better to keep the atmospheric losses to the atmosphere in the downlink to an extent which is as minimum as possible. That is why from the ancient days, from the beginning of the satellite communication, the 6 gigahertz, the conventional communication started in this C band, which is 6 gigahertz uplink and 4 gigahertz downlink. And therefore it was chosen to be the higher frequency which will give a higher, relatively higher atmospheric propagation loss, and 4 gigahertz for the downlink which will give relatively, in those days the TWTAs were only some 4 watts or at the most some 6-8 watts. So the signal that is transmitted from the satellite is much weaker than the ground station power that you are transmitting. To compensate for that, it is kept higher frequency in the uplink and the lower frequency in the downlink.
So, other than EM waves transmission, are they using any optical communication in the NASA or any other places?
Optical communication is used between satellite to satellite. Inter-satellite communication, optical communication is used, but not from the ground to the satellite or satellite to the ground. Maybe in the future it will come because we are talking of quantum communication, which is supposed to be using the invisible, the infrared links are used. Invisible infrared links are used for the quantum communication, but not in the visible optical range.
Thank you very much.
Thank you, ma'am.
Thank you.